All right, that was actually pretty quick today. Yeah, really. Actually, we probably both just jinxed it. All right, so number 4, the whole parallelogram. This actually was part of that first quiz. The new stuff was the rectangles, the rhombuses, and all of those. But parallelograms we've been dealing with. So as we kind of look at these, the angles are probably the hardest of them. Hopefully we're understanding these a little bit. I want to kind of go through these a little quicker so we can get through them all. So what we hopefully understand is that these are parallel. That thing just disappeared on me. It jumped the page. All right, keep going. Get as many as you can while I figure out where the heck I'm at now. As soon as I touched the screen, it just went away. Yeah, you're right. Let's just do this. I have it up. Here. Okay, let's try this again. Because this is a parallelogram, what that means is your opposite sides are parallel. So this side here and this side here those are parallel. So these diagonals then are your transversals. All right, what we had quizzed on was just these. We hadn't necessarily put them in terms of quadrilaterals and such, but these are transversals. So this angle here, this 32-degree angle, is an alternate interior angle to this angle. So we could right away say that's got to be 32. Now we'll kind of go and see which ones we need here in a second. But at this point, let's just fill in what we would hopefully know. Same with 48. Doesn't then 48, so this 48-degree angle is an alternate interior angle to this angle. So this angle here has to be congruent to this angle here. Those are both 48. Well, if that diagonal is a transversal, then wouldn't the other diagonal also act as a transversal? So let's draw in this transversal. So this 52-degree angle, I'll mark this one with 3 ticks, has to be congruent to this angle. So this is its alternate interior angle. So that also has to be a 52-degree angle. Regarding our angles, now we got to think a little bit. So we'll apply some of this, but hopefully just the idea of alternate interior gets us through all of those. We would know this side here has to be 21 because opposite sides are congruent. They're not just parallel, they're also congruent. Since the top side is 18, the bottom side is 18. If we start filling these out, my guess is most of these are taken care of. All right, so let's go through those now, and then there's probably going to, we'll notice we're missing a couple of angles here. Well, let's see which ones we now know just from those ideas. Let me clear out all of this stuff. So if I ask you RWS is this angle right here. We now know that is a 52-degree angle. If we find SYT, so here's SYT. So this angle here is one of the ones we're missing. But if that's an angle, look at this triangle that this is part of. Don't we know the other 2 of those angles? So if this is the angle that we're still needing, we can do 180 minus the 48 minus that 52. What is that, 100? So that's got to be an 80-degree angle. So this, we can fill in 80. If we look at angle RST, that's the one we're going to have to do a little work for. We'll come back to that in a second. RST is this big angle here. We have some of that angle. We know some of it is 52. We don't know this one just yet. So let's come back for that in a second. All right, WTS, so WTS, so from here to here to here, that's this big angle that would combine the 32 and the 48. So we would add those up. That's going to be an 80-degree angle. If I ask you WRT, so where's our WRT? That's super easy, right? WRT. Yeah, that one's given to you, so don't mess that one up. WRT was the 48-degree angle. And then the sides should be pretty nice. This would be 21, and then WT would be 18. So the last little bit of work is trying to figure out what this angle right here is. So RST is the missing angle. This full angle is what we need, but we need to figure this one out first. So look right here. Notice how this is a line. Doesn't a line, linear pair, all the old stuff, doesn't these two angles here have to add up to be 180 degrees? Well, if this is 80, no problem, Kim. This has to be 100 degrees, right? Because that makes our straight line. Now let's focus in on this triangle up here. Don't we know two of these three angles? We know one of them is 32 degrees. The other is 100 degrees. So if we wanted to figure out the missing angle right there, we do our 180 minus the 100 minus that 32. That is at 132, so 48. So this has to be a 48 degree angle. Although now that I think about it, we didn't even have to do that, right? There's so many different ways to do these. Like there's some different routes we could take. But now that we do this, let's go ahead and do this, and we'll talk about why we didn't necessarily have to do this. If I wanted RST, this full angle right here is the sum of 48 and 52. So if we added those up, that's a 100 degree angle. The reason we didn't necessarily have to do that, now that I do it and realize this, and all these different properties come into play, once we knew that this total angle down here was 80 degrees, in a parallelogram, aren't our consecutive angles supplementary? So if I knew this was 80, didn't the big angle up here then have to be 100? So that when we add these two up, they would give us the 180 that they're supposed to be. So just a lot of different avenues, again, like we've been saying. And you may see it a little bit. That's why I wanted you to practice on Friday, and you can approach them however you want. Okay? But the more properties you know, the more you know how to access them, the easier it's going to be. All right, number 5, rectangle now. Rectangle is first and foremost a parallelogram. So all the properties from above still apply to this. So we know our opposite sides are congruent. So in this case, we gave you the sides first, so that's good because the sides tend to be the easiest. So if I wanted AD, that's easy, got to be 7. If I want the length of a B, then I'm guessing this is B here. B is missing on mine. Is it missing on yours? Okay, yeah, so this is B right here, so label that. And then A to B would have to be the 24. So we know that's 24, we know that's 7. Those pretty straightforward. All right, then angle ABD. So I am looking for this angle right here. So what we said is a rectangle is first and foremost a parallelogram. So all those properties of parallelograms apply to this. One of the unique properties of a rectangle that bring it down our little flow chart that we had drawn in, that makes it a little bit different than just a regular parallelogram, is that they have 90-degree angles. So this full angle up here has to be a 90-degree angle. If both of those angles add up to be 90 degrees, and we already have 71 degrees of it, then this little missing angle in here, the only thing that could possibly be is 19. So this has to be a 19-degree angle. And then we can now label that one. Then DAB. So DAB is this big angle here. Write that down. We better know that one. So DAB is the big left-hand corner angle. Ahmed, what's that got to be? What does this big 90-degree? Oh, yeah, I just said it too. Yeah, got to be 90 degrees, right? Every big corner angle has to be 90 degrees. So good. All right, angle BDC. So BDC. So that's this angle here. Fill that in for me. This is hopefully the one we have done the most, the one that we had the hardest time recognizing when we first started doing all of these. Hope at this point we see this. We've already done it a few times today. All right, Becca. What do you think, Becca?
put like 71 next to it.
Okay, good. So you said one is 71, one is 19?
Yeah.
Okay, perfect. So in terms of BDC, so B to D to C, so that's this blue angle here. She said one of them 71, one is 19. That's because they're alternate interior angles to these. So this 19-degree angle is the alternate interior angle to this. So this has to be 19. And then the 71 is the alternate interior angle to this one. So we'll go ahead and fill them in. The answer to this question here, though, is the 19 degrees. But chances are we're going to need all those anyway. All right, good. All right, then angle DAC. So DAC. So now we're looking for that upper left-hand smaller angle right here. All right, and again, take some thought. And again, have your notes in front of you tomorrow. Look at the properties, read through the properties if you can't figure it out, especially as we start getting into the more complex shapes. The property we want to kind of focus on is in a rectangle, your diagonals are congruent. So this diagonal here and this diagonal here, those are congruent. Then in any parallelogram, they bisect each other. So if this whole length is congruent to this entire length, and then each of them gets cut in half by each other, what that would mean is this segment, this segment, this segment, and this segment would all have to be congruent. The reason that is important, so let me shade in the triangle now that we're focusing on. So we want this angle up here. So now look at this triangle here. And what we have right here, the yellow that I have shaded, isn't that an isosceles triangle? Two of the sides are congruent. Those are the ones that we have marked. So this side here is congruent to this side here. That means their opposite angles are also congruent. Don't we know this one is 71 degrees? So if they're congruent, then what that would mean is this one up here must also be 71 degrees. So let me erase this. The angle that we were ultimately worried about has to also be 71 degrees. Then AED, answer AED. Find that angle, do this. This is one that we should know pretty well. So, all right, I just erased that big triangle in here, but remember how I had this whole thing shaded in? That's one triangle. We know two of those three. So we're just doing 180 minus 71 minus 71. So what is that, 142? So do we get 38 degrees right here? All right. So that should be 38 degrees. And then D, E, C. We've already done one of these today. Is this angle right here? That's the angle we're trying to find. And then this is a linear pair with the 38 degree angle that we have. That those two together, the 38 degrees and that purple angle that we're trying to find, have to add up to be 180. So if I did 180 minus 38, that should be 142. Okay. That's our rectangle. All right, these now, a little bit of algebra. So these are a little quicker, not as many questions, but these are now the ones that you got to know your properties. You got to be able to set up your equation, solve the equation, and then make sure you answer your question. All right, so for this one, you are told that EFGH is a parallelogram. E to I is going to be 9x minus a 1. And then IG is 7x plus 15. This should be moved over here. All right, so in a parallelogram, again, please have the properties next to you tomorrow. If you have the notes in front of you and that's legal this year, take advantage of them. And what you will find, notice these are our diagonal properties. diagonals bisect each other. So these are this is the midpoint of both of those diagonals. So this segment here has to be congruent to this segment there. So our equation is simply setting them equal to each other and then working our way through solving that equation. All right, so we get 2x minus a 1 equals a 15. Add over the 1. X equals 8. Again, tomorrow, Thursday, when we're doing these little assessments, make sure you answer your question. Yes, X is 8. But the question is asking you, what is the length of E to G? E to G is the full diagonal here. So that's what we ultimately need from there to there. So if I were to take 8, plug that in, 9 times 8 would be, well, let's do it first, and then minus a 1. So that's 72 minus a 1. So this segment is 71. You could plug it in to confirm. It's not a bad idea, but doesn't this segment then also have to be 71? And then those two guys added together should give us this full length. So EG should have a length of 142. All right. All right, 7. Quickie. Do that one real fast. All right, Ella, what are you plugging in your calculator up there?
I did 180 minus 45.
Good. She did 180 minus 45. The theorem is consecutive angles. So here's the angle you were given. Here is the angle we are looking for. Consecutive angles, and the angles that are directly next to each other are supplementary. They have to add up to be 180. So she did the total 180, subtracted the missing angle, or the angle that we knew, and then the missing angle has to be whatever's left over, must be 135 degrees. Okay. The other property, just in case, depending when we finish, opposite angles are congruent. So that would have been 145 if I ask you that, which then would make this 135. So opposite angles are congruent. Consecutive angles are supplementary. All right, let me fix this messed up here. There we go. All right, number 8. Oh boy. Yours is formatted better than mine. So that tells you that in parallelogram EFG, angle E is 8x plus 6. Angle G is 5x plus 18. So I just gave you both properties of a parallelogram when we're talking about the angles inside of them. So see if we're adding, you're really only doing one of two things, right? They're either supplementary or they're congruent. So you're adding them up, setting them equal to 180, or you're setting them equal to each other. All right, and Rebecca, what'd you do? Good. They are opposite angles, so she set them equal to each other. And then that's your equation. Just make sure once you solve for x, know if that's what I am asking you for or not, because you may have some more work involved. All right, so we set them equal, subtract our 5x over. Let's subtract that 6 over. So what we get for x when we divide 12 by 3 is a 4, so that's good. But now what we're looking for, I'm actually not even asking for one of the angles that we just used. I'm asking for this angle up here. This is the angle that I want. So these are the ones I'd like to give you a few of tomorrow, and especially on Thursday for the test, where now you need to know both of our properties. Because what your next step is, we now need to plug 4 in for your x. So 8 times the 4 plus a 6 will add up to be 38. So the reason Rebecca set those equal is opposite angles are congruent, and then the one before it, opposite angles were supplementary. That's why Ella subtracted that from 180. So once we know that this, let's get rid of this now. I'll just type in 38, or write in 38 degrees. Then we would now get angle H by doing 180 minus 38. That's what remains for that angle. That would have to be a 142 degree angle, right? All right, 9. Let's see if we can set this up. Yeah. All right, hold on a minute. Did I mess something up? It's possible. Of course, now my word is frozen on me. Give me a minute. No, this is right. What, do you think I messed up? What was? Say that again, Cam. I didn't. I turned up my computer mid sentence. I didn't hear you initially. Correct. I would agree with that. What that would imply is, what's the actual length without using a variable? What would the actual? Is it? We wouldn't want to say how long. You know, you call the carpet company, and how long is your floor? You wouldn't want to say it's 8x. You'd want to tell them it's 16 feet, 18 feet, something along those lines. Okay. All right. So what this is now getting at, I'm trying to find the properties so I can just shift them to you so we can show you real quick, is this is a square, the one that you're looking at. I'm not going to find it. Let's just get going here. All right. A square, actually, it's a rectangle property. So, but a square is a rectangle. In a rectangle, which a square is, your diagonals are congruent. So these guys are congruent to each other. So E to G is this one. F to H is this one. Those are the two that you are given. Those have to be set equal to each other. Diagonals are congruent if you were looking at a rectangle. So even though I'm telling you this is a square is a rectangle. So those diagonals are congruent. That's your equation. So we're going to get a negative 4x equals a negative 4. Divide, and we get x to equal a 1. So now kind of to Cam's question, yeah, I gave you EG in terms of a variable, but now that we know x is a 1, then doesn't EG have to just be 8? Because EG I had given you was 8x. Now we know it's a 1, so the overall length has to be 8. Okay. Again, lots of properties here. Lots of properties. There we go. All right, number 10. The given figure ABCD is a rectangle. So it's really all the parallelogram properties along with the diagonals being congruent and the corners being 90 degrees. Those are basically the unique properties of a rectangle. And then I tell you that angle 1 is 68. So this angle right here is a 68 degree angle. I don't want to give you too much time, so I want to make sure we get as many of these as you can. But think this one through a second, because it's very much, you're probably 2 or 3 thoughts away from being able to get to x. You got to apply a few different properties here to ever even get over to the triangle where the x is at. And really, there's a couple different routes you could take to even get over there. Okay, because there's multiple ways to get this guy going, I won't take this opportunity away in case you have a different idea. Can somebody get me started on one way to get this going? Ahmed, what did you do? Okay, good. So what Ahmed did is he started with this angle down here, this big angle being a 90-degree angle. That actually was not my first thought. Okay, so he did it a little bit differently than I would have approached it initially. But knowing that, what does this angle here have to be, Ahmed? Good. So then he knows that's got to be a 22-degree angle, so those add up to be a 90-degree angle. Then what's that allow you to do, Ahmed? Good. So we've already kind of talked about this a little bit. When we do this, notice how we get 1, 2, 3, 4 triangles. They're all isosceles triangles. It's like we did earlier here when we did those rectangles. So because this side is congruent to this side, we know this side is 20, or that angle is 22. So what he said is we know this angle here must be 22. Then my guess, everybody now that you kind of see this would be like, okay, now that we got that far, we're probably good with the rest of it. Because what do we now know, Ahmed? Good. All three of these angles have to add up to be 180. So he just did 180. Let's get rid of those two 22s. So was that Ahmed? Good. Then it's got to be 136 degrees. Okay. Good. All right, 11. Set up your equation for number 11. See what you think. All right. Two properties we've already talked about today. In a parallelogram, look at these are both angles. So you're really dealing with one of two things when they're angles. They're either supplementary or they are congruent. Because these two angles are next to each other, they're certainly not opposite of each other. These are what we call consecutive angles. And in a parallelogram, consecutive angles are supplementary. So in this case, we want to be adding these and then setting them equal to 180 degrees. First time I think we've done this today, we've had to do the supplementary idea and add them. So when we do that, you just add your like terms on the left. I'm gonna need a little help here. Hopefully this is a good number. Did I do this right? Okay. Plus 41. Okay. And then 17x would equal to 21. Is it 13? Okay, good. I know you freak out. I'm starting to freak out too when we get decimals, but we're good. Should get x is 13. Now, see if that's the answer. The question is, what is the measure of angle E? It's up to you which one you want to find. Now that we know x is a 13, if you find this angle here, then they're congruent if you plug your x in there. If you plug your x into the other one, then it's supplementary. So it's up to you. I'm going to probably go with the one that's congruent. So let's take this 13, plug it in for that x. So 7 times 13 minus 28. This is my mental math today. And then that should be, what, 63? Is that what we're all getting? Okay. Because this is 63, the angle I was asking you for is opposite of that. Opposite angles are congruent. that's got to be 63 degrees. That's our answer. Okay. All right, here's what I'm gonna do. I'm gonna make that quiz. I'll probably give you 25 minutes tomorrow. I'll make it short enough to where 25 minutes hopefully is a legitimate option. And then the first 10 minutes, we'll just do a few more of these. If you want to see if you're ready, try these. Okay, it's only I think 3 or 4 questions. See if you get these right. So when we do them tomorrow, it's a little bit of an indication of whether or not you'll be able to do the quiz on your own, or if you're going to have some problems. But definitely have your packet. Definitely have all those properties ready to look at and reference when you go through this. Okay, but we'll spend a little bit of time tomorrow. We'll hit on these real quick, and then quiz tomorrow on this stuff. Okay, so a lot of stuff here. All right, with that, hope you guys had a good weekend. Have a good night, and we'll see you tomorrow.